Welcome back. In this video, we're going to explore access control lists, or ACLs, in Linux. Standard file permissions are great, but sometimes you need more granular control, like giving a specific user access to a file without changing the file's owner. That's exactly what ACLs allow us to do. First, let's set up our environment. I'll start by creating a file named guest.txt. Touch guest.txt. Let's check the default permissions with ls.l. As you can see, it's owned by the user LPICs and the group LPICs. Let's make some more dummy text files so that the difference between the files is crystal clear on which ACL is applied and on which not. This way we can make several files easily. Now, to demonstrate permissions, we need some other users. I'll try to add a user named guest. User add guest. Permission denied. I need root privileges for that. Sudo user add mguest. The m flag creates a home directory for the user. Now let's set a password for them. Sudo password guest. I'll do the exact same thing for a second user named John. Sudo user add mjohn. Sudo password John. Now, let's see what happens if the guest user tries to interact with our file. I'll switch to the guest user account. Su guest. I'm going to try to write to guest.txt using the cat command. Cat guest.txt. And press enter. As expected, we get a permission denied error. This is because the file is owned by LPICs and the guest user falls into the others category, which currently only has read permissions. Let's exit back to the main user. Exit. To fix this without changing the file owner, we use ACLs. First, let's view the current ACLs to see what we are working with. Getfacl guest.txt. Right now, it just shows the standard owner, group, and other permissions. Now, let's grant the guest user read and write access specifically. Setfacl, mu, guest, rw guest.txt. The m flag modifies the ACL. Guest specifies the user, and rw sets the permissions to read and write. Let's verify the change. Getfacl guest.txt. See that new line? User, guest, rw dash. That is our new ACL entry. Also, if we run ls.l, notice the +sign plus at the end of the permission string. That indicates that extended ACLs are present on this file. Let's test if it actually works. I'll switch back to the guest user. Su guest. Let's fill the password and now let's try writing to the file again. Cat guest.txt. Type hi there and save. Success. No permission denied error this time. Let's read the file back just to be sure. Cat guest.txt. It works. The ACL allowed the specific user to write to the file even though they don't own it. Exit back to the main user. Exit. ACLs are flexible. I can add permissions for John as well, without affecting guest. If we check with getfacl, you can see entries for both guest and John now. But what if I want to revoke access for just guest? I use the X flag to remove an entry. Setfacl, xu, guest.txt. Checking the ACLs again, you can see guest is gone, but John remains. Finally, if I want to strip all ACLs and return the file to standard permissions, I use the b flag, which stands for remove all. Setfacl, bguest.txt. Running getfacl shows we are back to the basics. And if we run ls.l, that plus sign is gone, confirming the ACLs have been removed. That's a quick overview of managing granular file permissions with ACLs in Linux. Thanks for watching.